Let's start the revision today. Hello, everyone. Good evening for all of you. Today we will finish our revision set with the last revision. As usual, I'll make all of you mute, and if you have any question at any time, please ask about it. And at the end, we will open the discussion. Then, if you have any question regarding to the exam or regarding to the revision, please ask about it. We will discuss about 25 questions today, ranging from paper 1 and paper 2. So let us start with the first question. What is the liquid paraffin? Liquid paraffin, is it a liquid saturated hydrocarbon or a liquid unsaturated hydrocarbon or a water-soluble ointment base, or this liquid paraffin causing constipation when administered orally? Firstly, liquid paraffin will lead to diarrhea, not constipation. It is not a water-soluble ointment base. Okay. So we have two choices. Either it is saturated hydrocarbon or unsaturated hydrocarbon. It is a saturated one. So the right answer here is saturated hydrocarbon. The next question. The right side of action for the following drugs. Here we have some diuretics and the mechanism of action at the site or regarding to the site of action. Furosemide. Firstly, what is the furosemide or what is it belongs to? It belongs to loop diuretics. So loop diuretics acts on the descending or ascending part of the loop of Henle in the nephrons. So this is a wrong statement. Spironolactone, loop of Henle. Spironolactone, one of the potassium-sparing diuretics. These potassium-sparing diuretics working on the collecting duct. Mannitol in the glomerulus. Actually, mannitol as an osmotic diuretic acts on all of the nephron parts. Thiazide diuretics acts on the distal tubule, which is the right answer. Okay. The last group of the diuretics is the carbonic anhydrase inhibitors, like acetazolamide. At which part of the nephron acetazolamide or carbonic anhydrase inhibitor works? It works
Proximal.
Yes. Proximal convoluted tube. You should know each group of diuretics and at which part of the nephron it will work. Let us summarize it again. This is the capsule, the proximal convoluted tubule, loop of Henle, then the distal, then the collecting duct. Here, carbonic anhydrase inhibitor. Here, loop, especially in the ascending part, loop diuretics. Here, in the distal, we have thiazide. And here we have potassium-sparing diuretics, while osmotic diuretics can act at all parts of the nephron. Next question. Which of the following is not metabolized by glucuronidation? Glucuronidation, as you know, it is the reaction that helps in attachment of glucuronic acid to a specific functional group of the drug to make it more polar and make it easier to be excreted from the body. It is one of the phase 2 metabolism. As you know, phase 2 metabolism is the conjugation reactions. One of the conjugation reactions is conjugation with glucuronic acid. Here we have different functional groups. Which of them not metabolized by glucuronic acid conjugation? Alkenes, C, double bond C, or phenol, or carboxylic acid, or acetaminophen, paracetamol. As you know, glucuric acid can attach it to carboxylic group, alcoholic group, amino group, sulfur group. So all of them can be metabolized by glucuronidation, except one, except the alkenes. C double bond C will not metabolize by this mechanism or this reaction of metabolism. So the answer is A, alkene. What is the leukocytosis? Is it an increase in the white blood cells or decrease in the red blood cells? We have anemia. Decrease in the platelets, we have thrombocytopenia. Increase in RBCs, we have polycythemia. So the increase in the white blood cells, we call it leukocytosis. Okay. The next question. Highest capacity of pulmonary volume. The highest capacity of pulmonary volume, is it tidal volume or vital capacity or forced expiratory volume or residual volume? The right answer here is it is the vital capacity. Yes, it is the vital capacity. A patient brings you a prescription for 16 milliequivalents of potassium chloride. Your pharmacy has 600 milligrams. Yes. If you have a question.
Can you explain what is the vital capacity?
Let's go back to this is the vital capacity. Vital capacity here, as you see, is the highest capacity of the pulmonary volume, highest capacity or highest volume of air that the lung can withstand. Highest volume of the air that the lung can withstand. Okay?
Okay, sir. All good. Thank you.
You see the calculation problem or this calculation regarding to the milliequivalence. How can we calculate the milliequivalence or the problems related to milliequivalence? Here we have 16 milliequivalents of potassium chloride. How can we get these milliequivalents from the number of tablets? Your pharmacy has 600 milligrams of potassium chloride as a controlled release tablet. So potassium chloride present in the form of tablets. How many tablets needed to prepare this prescription? 16 milliequivalents. Each tablet contains 600 milligrams of potassium chloride. Okay, so each tablet contains how many milliequivalents? Just divide 600 milligrams over the molecular weight, 74.5 here. Milliequivalents equal 600 milligrams, the weight in milligrams, over the molecular weight, over the small n. Here the small n equal 1 because we are dealing with potassium chloride. So the small n equal 1. When you divide the milligrams, the 600 milligrams over 74.5, you will get number of milliequivalents per tablet. 8 milliequivalents per tablet. Okay? So 8 milliequivalents per each one tablet. We need 16 milliequivalents. So how many tablets? Divide 16 over 8, you will get 2 tablets. Is it clear? Let's see the next question. How many optical isomers are possible for 2-amino propanoic acid? Here we have the structure of 2-amino propanoic acid. Propanoic acid formed of 3 carbons, 1, 2, and 3. At the carbon number 2, we have amino group. Okay. This is one of the alpha amino acids. How many optical isomers? How can we solve this problem? First, you should know how many chiral centers in order to apply the following formula. Number of stereoisomers equal the chiral carbon 2 to the power n. N is number of chiral centers. So we need to know what is the n. Here, how many chiral centers in this structure? Only one. Yes. One chiral center. Chiral center or asymmetric carbon means a carbon which is surrounded with 4 different functional groups. Let us see this carbon. This one surrounded by carboxylic group, amino group, methyl, and the 4th bond with hydrogen. So we have only one chiral center. How many stereoisomers in this case? 2 to the power 1 equal 2. So we have 2 optical isomers for this compound. Not a method for contamination. It is one of the repeated questions several times in the previous exams. Contamination here not meaning infection with a bacterial or viral or pathogenic organisms. Contamination here means impurities. Okay, the contamination of a powder of any drug means the impurities that present in this powder. We have 4 different mechanisms for impurities or contamination with impurities. Inclusion, precipitation, occlusion, or surface adsorption. Those are the 4 mechanisms of contamination. Surface adsorption. While exclusion is not a contamination method. Okay, so the answer here is exclusion. Type of radiation used in sterilization. Which type? Alpha radiation, beta, gamma, or ultraviolet? Of course, it is gamma radiation. Okay? The gamma radiation or gamma irradiation is the most popular form of radiation sterilization and is used when material are sensitive to the high temperature of autoclaving, but compatible with ionizing radiation. Let us see this question about enantiomers, diacylomers, or mesocompounds. Below we have 4 isomers of 2-chloro-nitrobutane isomer. Okay. What is the relation between the 2 isomers A and C? How can we solve a question like this? Let us put them beside each other in order to see the answer. Here we have the isomer A and the isomer C. CH3, Cl, H, and here we have H, here we have NO2, and here we have CH3. The isomer number C, here we have CH3, H, Cl, H, NO2, and CH3. To know if it is enantiomer or diacetylomer or mesocompound, we have several characters to apply. The first character, how many chiral centers present in this isomer? Here we have 2 chiral centers. Okay. The next character, the mirror image character. Are they mirror image to each other or not? As you see here, the Cl in the same side like Cl here. So they are not mirror image. Not mirror image to each other. The third character, the superimposable. Are they superimposed to each other or not? What is the meaning of superimposed? If you put one of them over the other, they are compatible, or they are typically like the other. If you put the isomer C over the isomer A, what you'll see, the first chiral center, you will find Cl over Cl. But the second chiral center, you'll find NO2 over H. So they are not superimposed. Not superimposed. Okay. The fourth character, are they optically active or not? How can we know the optical activity? We have a rule here saying that if we have odd number of chiral centers, directly the compound is, or the isomer is optically active. Okay? But if we have even number of chiral centers, then we should see if the compound is meso or not. If it is meso compound, so the compound or the isomer is optically inactive. If it is not meso compound, so it will be optically active. Here we have two chiral centers, even number. So we should know if it is meso compound or not. How can we know that? The meso compound here, if you bend the upper part of the compound over the lower part, they will give a mirror image. They will be typically like the lower part. Here we have Cl and H and O2. So they are not mirror image to the same compound. So it is not a meso compound. So that it is optically active. Okay? It is optically active compound. Now we have four characters. What are those characters for? Is it enantiomer or diastereomer? Two chiral centers, not mirror image to each other, not superimposed, and optically active, those characters for the diastereomers. So the answer here is diastereomers. Okay, is it clear? We differentiate between enantiomers, diastereomers, and mesocompound. If you have any question, please ask about it. The next one. You have a question about enantiomers. Let us go back. Enantiomers, we have four characters for enantiomers. At least one chiral center. At least one chiral center. So if we have a one chiral center, directly we can expect that it is an enantiomer. The second character, mirror image to each other. Both isomers should be mirror image to each other. Okay. The third character, not superimposed. And the fourth character is optically active. Okay, those are the four characters of the enantiomers. When we apply those four characters, you will find that A and B are enantiomers. How? They are mirror image to each other. They are not superimposed. We have two chiral centers, and they are optically active compounds. So A and B are enantiomers, while A and C are diastereomers. Okay? You have 20 milliliter ampoule with concentration of 0.75%. And you need to prepare 250 milliliter of solution with a concentration of 0.125%. What is the volume of liquid needed to be diluted? Okay. Let us see this question. This is a dilution question. We have concentration before and concentration after. Okay. What is the concentration before? Is 0.75%. What is the concentration after? After preparation or needed concentration is 0.125%. What is the volume before? Is not known. Even if we have 20 milliliter here, but here we can use several ampoules, not only one ampoule. And each ampoule by 20 milliliters. So here the volume before is not known enough. The volume after here, what is the volume of diluted solution? We need to prepare 250 ml. So we can use the dilution formula, C multiplied by V before equals C multiplied by V after dilution. We need volume before dilution, so it will be 0.125 multiplied by 250 ml over the 0.75%. Let's calculate it and see what is the answer. The volume before 0.125 multiplied by 250 over 0.75. It will be approximately 42 ml. Okay. What will happen if he asks about how many, instead of this, what is the volume of liquid needed? How many ampoules used to prepare this solution? Okay.
So 2 ampoules.
1, 2, 3, 4 ampoules. What is the right answer? 2 or 3? Yes.
3.
It is 3, not 2. Why 3? Here,
Is more than
2. Yes,
40.
more than 40 by even 2 milliliter. But if you don't use this 2 milliliter from the third ampoule, you will get different concentration. Okay, so you will use the third ampoule, but not all of it. You will take just 2 milliliter from the third ampoule. But in this case, you used 3 ampoules to make this dilution. Is it clear? This is a tricky question. Within the pharmaceutical, yes, again, which part? The part of number of ampoules? 3 ampoules have. Okay. Here we go through the calculation by the several procedure. We will get the volume before. The volume before dilution. So we need a 42 milliliters from the original concentration to prepare the diluted one. Okay? This 42 milliliter, from how many ampoules you can get this 42? If each ampoule formed of 20 milliliters. So ampoule number 1, you will get 20 ml. Ampoule number 2, you will get another 20 ml. Now we have 40 ml, but we need 42. So the ampoule number 3, you will get 2 ml. Okay? So you can use 3 ampoules. Is it clear? the next question. Within the pharmaceutical industry, the department which ensures the facilities and system adopted are adequate is here. This department ensures the facilities and the system. So what we called it, is it quality assurance or quality control? It is quality assurance department, not quality control. Quality control for the final product to check its concentration, its shape, and the other characters of the final product. While the facilities of the industry and the system, is it adequate or not? Here we have the quality assurance department. All are used in treatment of cystic fibrosis except Dornase alpha. It is used in acetylcysteine. It is used antibiotic and bronchodilators. It is used, while antifungal is not used. There is no rule for antifungals in this condition. Which laxative causes dependence? Psyllium, mannitol, bisacodyl, and glucosate sodium. Of course, it is bisacodyl. The stimulant laxative is the first laxative that may lead to dependence. Here we have a table, different laxatives and different types of them, the mechanism of action of them. Please, you have a question? All are true about GTN. What is the GTN? It is glyceryl trinitrate. One of the nitrates is a vasodilator. Okay. It will cause vasodilation. It is used in treatment of hemorrhoids. Yes, can be used for chest pain of angina, or available as enteric-coated tablets and ointment. It can be available as an ointment, but not enteric-coated tablet. It is sublingual because it is, or it has high first pass metabolism rate. More than 90% of it can be metabolized by the liver before it is absorbed to the systemic circulation. So we cannot use it as tablets or enteric-coated tablet. We can use it as sublingual tablet. Which is most true regarding linear pharmacokinetics? What is the meaning of the word linear pharmacokinetics? Linear pharmacokinetics means the relation between the doses as an x-axis and concentration of the drug. When we change the dose, what is the effect on the concentration of the drug? For first order pharmacokinetics, it is the linear. It means that as you increase the dose, the concentration will increase. This is what we call first order pharmacokinetics or linear pharmacokinetics. Okay. The rate of elimination depends on concentration, or the T-half depends on concentration, or as dose increase, the T-half decrease, or the T-half is dose independent. Here for first order pharmacokinetics or linear pharmacokinetics, all pharmacokinetics parameters are constant, or we called it dose independent. Does not depend on the dose. If you change the dose, we have a constant pharmacokinetic parameters, either absorption, distribution, T-half, volume of distribution, elimination, all of them are constant. Okay. While zero order or non-linear pharmacokinetics, here we have dose-dependent T-half. When a drug has a first pass effect in the liver, that's mean it has long duration of action Of course not. Has a high systemic effect? Of course not, because it will not absorb the systemic circulation. It will be metabolized and excreted. It has less systemic effect. This is the true answer. The highest negative inotropic drug. Which of those is the highest negative inotropic drug? Here we have different types of calcium channel blockers, either dihydropyridines or non-dihydropyridines. The non-dihydropyridines related to the heart more than the dihydropyridines. So the negative inotropic effect with non-dihydropyridines more than the dihydropyridines. We have verapamil and diltiazem here as non-dihydropyridines, which acting on the heart more than the vessels, while dihydropyridines acting on the vessels more than the heart. Which of them having the most negative is verapamil, the highest negative inotropic effect? It is the verapamil. What is the meaning of rancidity? Rancidity of the C double bond. C means oxidation. Oxidation of the double bond of fatty acids. Esomeprazole will cause increase in absorption of itraconazole or decrease or increase clearance or decrease clearance. So here we have an interaction between one of the PPIs plus azole antifungal. What is the type of interaction here? The interaction here related to the effect of the PPI on the acidity or on the pH of the stomach. PPI will increase the pH of the stomach. Okay, so what will happen? Azole antifungal needs acidic medium to be absorbed. So if you decrease the acidity, the absorption will decrease. Therefore, the right answer here is decrease the absorption of itraconazole, which is safe in pregnancy. Aciclovir, like lisinopril, sulfonamides, warfarin. Of course, it is aciclovir. Lisinopril, ACE and ARBs, they are category X. Sulfonamides is not safe. Warfarin also category X. Which of the following have no active metabolite? Is it codeine? No. The active metabolite of it is morphine. Imipramine, the active metabolite is disipramine. Nifedipine has no active metabolite, while clopidogrel is a prodrug and the metabolite of it is the active. All the following are acceptable uses of magnesium hydroxide, except magnesium hydroxide is a salt that leads to diarrhea. So we can use it in constipation. We can use it as antacid, so for heartburn and dyspepsia. But for hemorrhoids, here we have no direct use or therapeutic use. We can use it in hemorrhoids to avoid the strain, not to treat the hemorrhoids. It is a very powerful laxative. Drugs that have different crystal structure, so different in polymorphism, solubility, crystallities, or drug form. Here, this is the definition of polymorphism, having different crystal structure shape. The same formula, but the structure shape having different shapes. So we call this character as a polymorphism. The last question today, treatment of trichomonas vaginalis. Is it metronidazole, amoxicillin, doxycycline, or miconazole? Of course it is metronidazole. This was the last question today and the last question in our revision. Okay? Still, you can join the revision. It is now updated and uploaded in our website, so you can join to the full revision and see all the lectures, including the pre and the full revision lectures. Okay? Plus the mock tests. The mock test is an important one for you before the exam. It is a resemble or mimic the real exam. Okay, it is formed of 2 papers, each one having 100 questions, and you can solve it within 120 minutes, like the real exam. Also, several questions in the mock test present in the real exam. The previous colleagues saying that they have several questions from the mock test in their exams. So it is an important one. You can join the mock test through this link. Okay, and I prefer to do the mock test as you are in the real exam. How? Start with paper 1. Then when you finish it, you can take a break for 1 hour, an optional break, maximum 1 hour. Then directly start paper 2. Then after that, you can see your results. Okay, this is the best way to practice the mock test present in our website. Still, I'm with you. So at any time, if you want any question, you can send it to me in the WhatsApp number. I'll be with you till your exam, and I hope all of you having a good luck in your exam. Okay? I'm very happy with you in this revision set. And let us open the discussion now. If you have any question. We have a question here from Ahmed Ali. How to memorize the pharmacokinetics formula? What are the most important? We have several pharmacokinetics formula. All of them are important. There is no specification for one to another. In order to solve the pharmacokinetic calculation problems, the first and the second and the third way is to memorize the formulas. Okay? The formulas are not difficult. They are not difficult. They are easy to memorize. You should collect them by yourself. Starting from the formula of the T half, 0.693 over the K. The formula of the dose, which equal plasma concentration multiplied by volume of distribution, or the loading dose, which equal CSS multiplied by VD. The CSS, which equal R, the rate of infusion over VD multiplied by K. Or if we have an oral, this is if we have an infusion. If we have an oral, the oral administration, the CSS equal bioavailability multiplied by the dose over VD multiplied by the K multiplied by the dose interval. Another formula, the total clearance equal VD multiplied by the K. Okay? Those are the most formulas that you will use, plus other formulas. All of them are important. So try to collect them by yourself. This will help you to memorize them. Okay? The dose interval means how many times you can give the dose. For example, if the drug is given twice daily, what is the dose interval in this case? If we calculate the time by the day, so 2 per day. Okay. If we have the time by the hours, so we have 12 hours. This is the dose interval. What else?
Good evening, sir. Can I ask you a few questions from the, the previously what you already discussed that, the recall
Mhm.
revision lecture? Yeah, I have a doubt about that question. Is the first question is all of the following can cause hemolytic anemia, except,
Mhm.
and the options are methyl dopa, cefotetan, glucose 6-phosphate dehydrogenase deficiency, and the beta blocker.
Mhm.
And the answer over here is glucose 6-phosphate deficiency.
Oh, the beta blockers. The right answer is beta blockers. Will not cause hemolytic anemia.
Okay, so it's D answer then.
Mm.
All right.
Regarding to the dose interval again, which will we use? This is depending on the unit of the time of the TH. If the unit of the time by days, you should convert it into days. If the unit of the time by hours, so you should use the hours. So make the units of all figures are similar to each other. And this is depending on you, not one system. Okay. So if we have the T half, for example, T half equal 24 hours. And he say that the dose is given twice daily. So we can use 1 hour. Okay.
So I have a question,
Yes.
not for the revision, but general question. Like exam is on 15th and 17th. If you have a student, those who are giving an exam on 15th, could you please share their feedback and the revision, what
Yeah,
type of the
we'll
question
do
they are?
that. We'll do that in our groups. Don't worry about that.
Okay. Okay, thank you.
Okay. What else? You have any question? Okay. Still, I am with you at any time. If you feel that you have any question or if you need any help, please don't hesitate to contact with me. Okay. So for any queries or for any question, you can contact with me directly. I'll be happy to help you at any time. At the end, I would like to thank you so much about your attendance of this revision. I hope it was useful for all of you, and I hope all of you having a good luck in your exam and pass from the first attempt as the previous colleagues. Thank you so much and see you soon. Goodbye.